Hey pre-calc students, welcome to another day on solving trig equations. Let's go ahead and start with number 1. So if you look at number 1, the trig function is linear, so it's just sine of theta to the first power. If you compare this to some of the linear equations you solved as a freshman, okay, you used something called inverse order of operations to solve. So you canceled addition and subtraction first. And your goal was to isolate the variable. In this case, we're trying to isolate the trig function. The root 2 is just a coefficient to the trig function, so you just divide it. So sine of theta is -1 over root 2. Now, for those of you that are like, but miss, you've always told us that we can't have a root in the denominator. Well, that's an improper way to write an answer, but technically -1 over root 2 is not our final answer. It's only there to help us remember that they're asking us what angle, sine of what angle is opposite over hypotenuse, or whose opposite and hypotenuse is -1 over root 2. So feel free to rationalize it and write it as -root 2 over 2, but I'm going to leave it like that because out of my two choices for special triangles, the 30, 60, 90, and the 45, 45, 90, I can tell from this fraction of 1 over root 2 that I'm going to be using a reference angle of pi over 4. So again, feel free to rationalize if necessary, but you don't have to because that's not our final answer. So this piece of information, these two pieces of information tell me two things. One, that the reference angle I'm going to be using is pi over 4. Two, sine is negative. So I'm going to ask myself, in which quadrants is the y value negative? Because remember, sine corresponds to the y value. Those are quadrants 3 and 4. So what I need to do is remember that my reference angle is pi over 4. So I'm going to imagine the top half and the bottom half split into 4 sections. I'm going to go ahead and label them. Now, we are doing this over a domain of 0 to 2 pi, 0 included, 2 pi not included. So remember, we're focusing only on positive angles here. Now, some of you have realized that you don't have to draw out and label each of these individual angles. You really only need to, some of you only need, 4 pi over 4 and 8 pi over 4 to figure out what these answers are going to be. All right, so I'm going to draw my special triangles in quadrant 3 and quadrant 4. So reference angle of pi over 4. So label your side lengths. And your solutions are the angles that end in those quadrants. So the solutions here would be that theta equals 5 pi over 4 and 7 pi over 4. Remember, you can pause and rewind the video at any point. All right, take a look at this next one. It's a quadratic, but it only has a quadratic term. It doesn't have a linear term. So one strategy that I like to use whenever I have a quadratic equation with no linear term is I also use SADMAP, which is backwards order of operations. So I start with canceling addition and subtraction. Get rid of multiplication or division. Remember, your goal is to isolate that trig function. Reduce. Now, I need to solve for the trig function, not for the squared version of it. So in order for me to get rid of that squared, I need to square root both sides. That will get rid of the squared, and I finally have my trig function isolated. But quick reminder, when you're squaring a fraction, you got to square root the numerator and the denominator. So this is going to be 1 over 2, but you also need to put plus or minus. Anytime you're solving a quadratic and you square root both sides, you need to put plus or minus and then your answer. So go ahead and pause the video right now and ask yourself, what reference angle am I going to use? So remember, these two pieces of information are enough to tell you what your reference angle is and what quadrants we're going to be looking at. So I want you to figure out which reference angle is going to work that will give me adjacent over hypotenuse of 1/2. Go ahead and pause the video. Unpause it when you find it. Okay, your reference angle is going to be pi over 3. Oopsies, I just realized I labeled those wrong. Okay. So 3, 1, and 2. Okay, so adjacent over hypotenuse, you'd have to use root 3. So the reference angle is pi over 3. My goodness. And the fact that they told us that I want cosine to be positive or negative, that means that the x values can be positive or negative. That can happen in all 4 quadrants. So we're looking at all the angles with a reference angle of pi over 3 in all 4 quadrants. So as I draw that out, actually, because it's odd, I want to cut the top half and the bottom half into 3 equal pieces. Again, you don't have to do this. You really only need to label 3 pi over 3 and 6 pi over 3, which are the ones that reduce to pi and 2 pi. And then fill in your triangles. So remember, your reference angles are pi over 3 in all of these. Okay, so opposite and adjacent, here would be -1, here would be +1. The solutions in this case are all those angles that land in those quadrants. So theta is 1 pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Okay, so let's take a look at a similar one, but with terms on both sides. So I noticed right away that this is also a quadratic, and there are no linear terms. So I'm going to try to use StatMap here, but right away I noticed that I have a trig function on both sides, and they are like terms. So I'm going to go ahead and combine them. So this represents a -1, right? This is a 3. So I like to, it's kind of like when you had the same variable on both sides, you canceled the smaller one. Some of you learned to do it that way. So I'm going to go ahead and cancel a -1 sine squared x. And then I'm going to continue isolating the trig function. So you see, very similar to the previous problem that we did, where you're going to square root both sides, and you're going to end up with plus or minus 1/2. But this time it's sine and not cosine. So when you're looking at your 30, 60, 90 triangle, The reference angle here for opposite over hypotenuse is going to be pi over 6. In the previous example, it was pi over 3. Because of the plus or minus, I'm looking for any angle with a y value that is positive or negative and has a reference angle of pi over 6. In any of the 4 quadrants, because of the fact that it's plus or minus. So again, feel free to label all 6 pieces. So in this case, you're cutting the top half and the bottom half into 6 equal pieces, right? It's going to be this guy over here, this one, and this one. That is 1 pi over 6. This is 6 pi over 6. This is 12 pi over 6. So your solutions are going to be 1 pi over 6, not 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, not 6, 7 pi over 6. So remember, these are the answers over here, these guys here. And last but not least, 11 pi over 6. Okay. For the next example, we have a quadratic trinomial. So I explained that to some of you. It might be easier to factor it without the trig function, you know. Think of it as if it just had the variable x. So factor it first. Now everyone factors differently, so you're gonna have to just double check to make sure that you're factoring it correctly and that your strategy works consistently. But if I distribute this, I'd get 2x squared minus 1x minus 4x plus 2. So it works. Okay, so I'm going to go ahead and factor it over here. That's going to be cosine of x minus 2 and 2 cosine of x minus 1. Because both of these factors are linear, I need to set each one equal to 0 in order to keep solving. So add 2 to both sides, right? You're going to add 1 and then divide by 2. So now we need to ask ourselves, what reference angle do we want to use? So out of my 2 options of triangles, and of course the quadrantal angles are always fair game as well, which triangle would, if I use adjacent over hypotenuse would be 2 over 1. Looking at both options, neither pi over 4, the 45, 45, 90, or the 30, 60, 90 would ever give me 2 over 1. I could get 1/2 if I used pi over 3, but I can't get 2 over 1. So this one is not possible. This is considered an extraneous solution. It means we did the math right, but it just doesn't work out. So again, I mentioned that I could get 1/2 for adjacent over hypotenuse, but not 1 over 2. And I could get adjacent over hypotenuse by using pi over 3 as my reference angle. Now cosine is positive. That means that I'm only looking for the x values to be positive, and x values are only positive in quadrants 1 and 4. So again, feel free to label all of the pi over 3's, right? 2 pi over 3, etc. 3 pi over 3. I did not label these on the y-axis because technically when it's a denominator of 3, you're cutting each top half and bottom half into thirds. So the y-axis isn't really part of that division. Okay, and I only want the ones in quadrant 1 and 4. So that's going to be pi over 3 and 5 pi over 3. So adjacent over hypotenuse for both of these would be 1/2. So theta equals pi over 3 and 5 pi over 3. Okay, last one. We've got another quadratic trinomial that I strongly recommend that you factor as if it didn't have the trig. Once you factor it, now obviously if you don't know how to factor, you're in a little bit of a pickle, right? You've heard that expression. So you're in a little bit of trouble. Because now the factoring is just the first step. You still need to replace it now with the trig. Set each factor equal to 0. And solve. So I'm going to add the 1, divide by 2, add the 1. Now, sine of x equals 1/2 requires me to use a reference angle of pi over 6. So look at your 30, 60, 90 triangle. That's 30 degrees. The y value is the one that corresponds to sine. Y value is only positive in quadrants 1 and 2. So if you draw it out, right, I only want pi over 6 and the one right before 6 pi over 6, which is 5 pi over 6. So 1 pi over 6 and 5 pi over 6. Notice I did this one a little bit faster, but you can always pause and rewind the video to give yourself time to figure it out. Now in this one, sine of x equals 1, I know that neither 30, 60, 90 or 45, 45, 90 would work. So that means it could possibly be quadrantal. Now remember, this is a y value. The only ordered pair that has a y value of positive 1 is this one. And that angle is pi over 2. As always, if you need any help, feel free to reach out to us, and have a great day, guys.